Alright, hi friends. I'm planning on telling you how to do linear equations, because those are really important. They really are. You're going to use these for like ever in all of the math classes. I haven't taken all the math classes, but since I learned them, I have been using them in every single math class, which, like I said, is not all the math classes, but I hope you understand my point. Understanding linear equations is also helpful, or at least it's been helpful for me to figure out other kinds of equations like quadratic, etc. It's just a good place to start and know what you're doing. First, a linear equation is an equation that makes a straight line in a graph, like I've just shown you here. When you graph one, you would actually put arrows on the ends where it touches the edges of your graph to show that it goes on forever, because it's a line and not a line segment, which I can explain if you want at another time. This one doesn't have arrows on the ends because I just screenshotted it from Desmos and I was too lazy to add arrow ends. There is a numerical representation or something like that, and it's the equation part. This is the graph right here. It's the equation part is what I'm talking about. This is the basic format of the equation that you would use to represent a linear equation. It's the one that I'm pretty sure they showed me first anyway. By the way, in case you forgot about variables, all of these letters are placeholders for numbers. Typically for graphs like this, the one you solve for is y, so that's why it is where it is on this one side of the equation by the equal sign by itself, that it's already all set up so that you don't have to move stuff around and do algebra to get your y coordinate from the other things that you have. This m right here, that is the slope. I will explain that later, kind of, I guess. I don't know how to explain that. I'm gonna kind of sort of do that. Hopefully you get it. If you're given the linear equation in equation form, you should pretty much always have this number. It's possible that you won't, but you probably will. And there's this b here. The b represents the y-intercept. I'm pretty sure that's not what they told me it was right off the bat. I don't think they called it that, but I don't remember what that was. I'm going to ignore it. Fill in any of the gaps you need to yourself. This is where the line that is on the graph that you graphed from the linear equation, or something like that, that's where it touches the y-axis. There is only one in a linear equation. There is only one in nearly all the types of common equations. There's a whole unit somewhere where they taught me how there aren't supposed to be two of these, and I don't remember it, and you're not there yet for this video, so one singular linear equation definitely doesn't have two. That's all that's important. Then there's x. The x is the number on the x-axis. This is graphing. That's how graphing works. You don't always start with the x, but usually you do, because you're trying to find the y value for when you put a certain x value in. When you're trying to find the zeros or the roots, you might put 0 in for y and then solve for x, and then you can find out which the x-intercepts are, because they're like, when y is 0, the line touches the x-axis, yeah? If you're graphing an equation, you might just pick an x value and then you just put it through the equation and you plot a point, and that's how you start in this graph. So the y is the number on the y-axis, which I kind of sort of already talked about. You almost never begin with knowing it. How we're going to start this is we're going to have an example thingy that I made up, and this is another Desmos screenshot, and the plan is that we find the equation for the line on it, that red one, right there. So they always tell you, or they always told me anyway, rise over run. And I was like, what does that even really mean? You just hear it and you're like, it goes in one ear and it goes out the other, and you're like, what on earth? And it doesn't even sound like anything. It is kind of easy to remember, and if you think about it a little bit, then you kind of get it, I guess. It's an easy way to remember it if you understand it. What it means is that the increase in the y value divided by the increase in the x value between 2 points on the line, and that's the slope. So what we need is 2 points, and I picked these 2 points. And we're gonna make like a right triangle with these. A triangle with a right angle on it, right? You have this line. This is my rise. This is my run. This right triangle thing is huge, and it would need a lot more simplifying fractions than is necessary, which is never the goal. So we want maybe a smaller right triangle with 2 points that are closer together on the graph. So then we're going to pick 2 points closer together and make a smaller one, which is right here. This run is 1 unit long. It looks like it's 2, but I actually did a weird thing on accident, and the little lighter gray lines are 0.5 units wide instead of 1, so like half a unit. That's 1 because the run spans 2 of them. That's 1 unit long. This other one, the rise, is 2 units tall or long. It doesn't particularly matter, as long as you know it's the rise. Then we're going to take these numbers and we're going to put them into the rise over run thing, make it a fraction. It's 2 over 1, 2 divided by 1, and that's pretty easy. It's just 2. And that, we know now, is our slope. Our slope, m, is 2. And we're going to put that in our equation because we need that. That's what we're looking for. Here's 2 right here. We got y equals 2x plus b, and we still need to find some other numbers. There's actually another way you can find the slope, and it's not quite as simple, but it always works, even when the slope isn't quite as obvious when like it is here. It's the same equation that you use later for average rate of change. So for find it, we need 2 points, just like before, which we have here, right? I have these 2 points. We're going to use the same 2 points as for the smaller triangle. And we also need their coordinates. I have 2, 9 for this one, and I have 1, 7 for this one. And then here's our equation down here. What we need to do is we're going to say this point is point number 1, and this point is point number 2, and it doesn't matter which one is which, because if you do it right, the result should be the same either way. And then we put the numbers from that into the equation. So like if, for example, I were to say that 1, 7 is point number 1, then I would replace y subscript 1 with 7 and x subscript 1 with 1. And then I would replace y subscript 2 and x subscript 2 with 9 and 2, respectively. This is especially helpful for when your points have decimals and things like that. It's just another way. We have the slope, we have m. I got rid of all that stuff except the important things that we're going to need to know for the full equation later. And now we're going to find b. I told you earlier that b is the y-intercept, which is where the line intersects the y-axis, where they touch, or one goes through the other. All those things. That's really easy right here. You can see it. It's just right there. I put a point on it. Sometimes you can't see it though, or so what do we do then? If you're working on your graphing calculator, you can use the trace button and press 0 to set x to 0, and it'll just tell you the point at which x is 0, which is the y-intercept. My calculator does that anyway. I don't know about Desmos or whatever your graphing calculator is. You can also find the y-intercept by taking the slope and finding what you get for a point you have without considering b, and then seeing how far off you are from that. So like 2x, normally if we were at like 2, if x equals 2 and we're at 2x, then normally y would be 4, but it's not 4 in this one, so we know that it has to be plus what number here. And right here, the y-intercept is 0, 5, but we only really care about the y value here, which is 5. So b is 5. And that's the y-intercept. That's b. There's 5. There's another equation for this line. Crazy. Great. Now you know kinda how to do that. Next, we're gonna graph a line from a linear equation for variety and experience, and just in case it's useful for you. I have this graph also screenshotted from Desmos, but this time it has no line on it, because we're gonna put it there. And here's my linear equation that I made up for this. I put a fraction in there this time because I'm just fancy like that, I guess. And you only need 2 points to make a straight line, which is what we're making. First, we want to graph the y-intercept because we know that already and don't really have to do anything to get it. It's just 2, 0, 2. That's half our points already. So 1 to go, friends. Since there's a fraction here, and it would be a lot easier to get a point with only whole numbers because of the whole it's easier to plot situation, I'm going to pick x equals 4 for the second point. Let's see, 3/4 of 4 is 3, and then we add 2, so that's 5, and then the point is 4, 5. Now we have both points, and we can draw a line there. And I put arrows on it because I'm fancy and I drew it myself this time. That's all. If there's more you want to know or you feel you failed to understand at my fault or something, ask me in the comments, or I don't know, you can find my Deviantart, my Instagram on my channel page somewhere. Or if you actually know me in person, you can ask me like that. I can probably explain some other stuff too. Can't guarantee anything, but I will try my best. I hope this helped you understand what you wanted to.